Center is pictured below. Find their weight, and you have all of this information. This says 0.28 meters if you can't read it. Pause the video now and try the question. It might seem like you don't have enough information to answer this question, but you can answer it quite easily if you understand moments well. So it seems like we have four forces and only two known ones. So it seems like there's two unknown forces, but we can use our principle of moments, which says that the moments about a point are equal if the object is in equilibrium. Now, that is not fully the principle of moments. What we really mean is the sum of the clockwise moments equals the sum of the anti-clockwise moments. So if we pick our pivot point carefully, we can solve this. So if we pick our pivot point at the force that we don't know, so if we pick our pivot point for force C, then we can eliminate force C from the problem and we can find out the unknown force. What we're really saying is moment is force times perpendicular distance. So if we make C the pivot, the distance to the pivot is 0. So of course the moment of C is 0. Obviously there will still be an upwards force there, but the moment will be 0 about this as a pivot point. So let's take moments about C. So let's think, what are all the clockwise forces? We've got force A times by 0.60 meters. We've also got force B times by the distance, which is going to be 0.6 minus 0.43, because we want this distance here, 0.17 meters, and that's going to equal the anti-clockwise moments, which is the weight times by the distance to the pivot, which is 0.6 minus 0.28, which is 0.32 meters. Now we've been given force A, that's 280 newtons. So we can replace some of these unknowns. We know what force B is, 150 newtons. And we're trying to work out W. So now we can solve the equation for W. So we'll type all our numbers in the calculator. Just going to double check that I've got that right. Always useful to double check your answers. I've got a different answer, so I'm going to do this one final time just to make sure I've got it right. And I've got the second answer again. So we've got our W is 604.6 newtons, and I'm going to round that to 605 newtons. Now there's one more part of the question, which is to find force C. So pause the video now and complete this question. So you could repeat this process by taking moments about one of the other points. There's nothing wrong with doing that. There is also a slightly quicker way. We can say that if we know what force A is, and we know what W is, and we know what force B is, then we can work out force C by purely just considering the upwards forces and the downwards forces. This person isn't accelerating up or down, so the total sum of the upwards forces must equal the sum of the downwards forces. So we must have the weight, which is 605 newtons, must equal 280 newtons plus 150 newtons plus force C, which means that force C is going to be 175 newtons.